Hey everyone, in this video I'll be sharing some real scenario based microservices interview question for the experienced candidates. And guys, these are kind of tricky questions you might actually face in your upcoming interviews. So watch this video till the end and don't forget to like and subscribe. So now let's get started. First question is, you have three microservices: order service, payment service, and inventory service. Order service calls payment and then payment calls inventory. So what happens if payment succeeds but inventory service fails? So guys, if payment succeeds but inventory fails, we get an inconsistent state. Okay. Money is deducted but the item is not reserved. So the order cannot be completed. Okay. So to fix this, we should use rollback refund mechanism where payment is reversed, retry mechanism where try inventory again, Saga pattern where automatically undoes previous steps. Okay, are you getting my point? So guys, next question is how Saga pattern automatically undoes. Could you please explain its mechanism thoroughly? So guys, Saga pattern works like a step-by-step transactions with a backup plan. Here in this, a big process is broken into the smaller steps. For example, order, payment, and inventory. Each steps completes its own work and saves it. If all steps succeeds, then it means process is done. If any step fails, then it means systems runs. Compensating action means undoing steps. Are you getting my point? For example, if payment succeeds but inventory fails, then Saga triggers a refund to undo the payment. Okay. Next question is, guys, could you please explain choreography and orchestration styles of Saga pattern? In choreography, there is no central controller. Each service works independently and reacts to events. For example, when order service creates an order, it sends an event. Payment service listens to it, process payment, and then sends another events. Inventory service listens and continues the process. So basically, service talk through events and decide themselves what to do next. Okay. Whereas in orchestration, there is a central coordinator that is called orchestrator that controls everything. It basically tells each service what to do step by step. For example, the orchestrator tells payment service to process payment, then tells inventory service to update the stocks. If something fails in between, it also tells service how to undo actions. Are you getting my point? So here one central service manages the whole flow. And next interesting question would be, guys, each microservice has its own database, but sometimes you need data from another service. So will you call another service every time or duplicate the data? So this is very tricky question. So basically in microservices, we should not call another service every time because it can slow things down and create dependency between services. Okay. Instead, a common approach is to duplicate only the required data, called data replication. Services shares update through events, so each service keeps a small copy of the data it needs. This makes system faster and more reliable. Okay. Hey guys, before moving to the next question, I would like to share one important thing with you. Actually, we have a complete interview preparation material structured step by step by myself, expert and MNC's interviewers. And the best part is that now no one need to go anywhere else to prepare interviews. There is a 99% chance that interviewers will ask questions from this material. Okay. And guys, in order to verify, you can check the reviews as well. So basically it contain a lot of material categorized by experience level, means each experience level has a different material with all possible interview question and answers for the with all possible interview question and answers for Java, Spring Framework, Maven, Git, Spring Boot, Spring Security, Spring Data JPA, Kafka, Microservices, Java coding questions, Stream API coding questions, and many more. I have provided the link to get this in the below description. And guys, if someone need this complete material plus two enterprise client projects for the reference plus one-on-one lifetime doubt sessions and referrals to the big MNCs, then they should check the interview preparation kit. I will provide the link for this as well. So now moving to our questions. Guys, next question would be, why does each microservice should have its own database? So basically each microservice should have own database to stay independent. This is the first thing. This means one service can change, scale, or even fail without affecting others. If multiple services share the same database, they become tightly connected. A small change in one service can break others and making the system hard to manage. Okay. Next question is, guys, your system has an API gateway and suddenly traffic increases heavily. So what would you do in this situation? First, we would scale the API gateway horizontally and add more instances and put a load balancer in front to distribute traffic. Okay. Second, we would apply rate limiting so one users cannot overload the system, and use caching to reduce the repeated request. Third, we would use a queue like Rabbit or Kafka for heavy operations so requests don't fall immediately. Okay. And the next question is, guys, why should we use an API gateway instead of calling service directly? So very important question. So basically, we use an API gateway to simplify and secure communication between clients and microservices. If client calls services directly, they need to know multiple service URLs, handle different responses, and manage complexity. With an API gateway, the client calls one single entry point and the gateway routes the request to the right service. Okay. It also handles common tasks like authentication, logging, rate limiting, and caching, so each service doesn't have to do it. So, guys, next question would be, in microservice architecture, share the scenarios when would you choose synchronous and asynchronous. So, guys, we should use synchronous communication when we need an instant response. For example, login, payment confirmation, validate users, etc. We should use asynchronous communication when work can happen in the background. For example, sending emails, notifications, updating reports, analytics, long running tasks, and reducing load during high traffic. Okay. And the guys, next question would be, one of your service is down, but your application keeps calling it repeatedly. How would you handle this? So if one service is down and our application keeps calling it again and again, it can overload the system and make things worse. Okay. To handle this, we use a few simple techniques. First technique is circuit breaker. It means stop calling the failed service for some time. After repeated failures, let it recover. Okay. Second is retry with delay. Instead of calling immediately again, wait like a few seconds before retrying. Are you getting my point? Third is fallback. Show a default response like service unavailable or try again later instead of failing completely. Okay. And fourth is timeout. Here, don't wait forever for response. Wait only for a fixed time. Say 2 seconds, then stop and move on. Are you getting my point? And guys, next question is, a request fails somewhere across five microservices. How would you debug? So first, we should start by tracking the request end to end. Okay. Then use a request ID so we can follow the same request across all microservices in logs. Okay. Check logs step by step to see where it fails. Are you getting my point? Then check each service one by one. Look at the logs, errors, and response codes. Verify if any service is slow, down, or returning wrong data. Check dependencies like database, API calls, or queues. Are you getting my point? Finally, use tools like distributed tracing, for example, Zipkin or any other tool, and monitoring dashboards to quickly spot the failing service. Once found, fix the issue, add alerts to catch it earlier next time. Okay. Guys, next question is, you want to deploy a new version without downtime, how would you do it? So guys, we should use zero downtime deployment techniques here. First is blue green deployment. Here, run old and new version side by side. Switch the traffic to the new version once it is ready. Okay. Second is rolling deployment. Update server one by one so the application stays live. Are you getting my point? Third is canary deployment. Here, release to a small group first, then gradually to the users. This way, users don't face any downtime during the updates. Next question is, guys, a service fails due to temporary issues. So how will you handle this situation? So guys, in this situation, we should use retry and delay mechanism. If service fails, wait for a few seconds and try again. We say retry. Limit retries, example 3 times to avoid overload. Okay. We could use circuit breaker here as well. If it keeps failing, stop calling for the some time. Okay. We could also add fallback like show try again later or used cache data. Okay. Next question is, guys, let's say a payment API is called twice accidentally. How will you ensure duplicate payment doesn't happen? So here we should use idempotency, basically send a unique transaction ID with each payment request. If the same request come again, system checks ID and ignores duplicates. Store request status to prevent double processing. Okay. Next question is, guys, in microservices, how would you handle transactions across multiple services? So in microservices, we don't use one database transaction across services like in monolithics, because each service has its own database. Okay. Instead, we use the Saga pattern. As we already covered this in the earlier question, the transaction is broken into the small steps and each service complete its part. If all steps succeeds, transaction is complete. If something fail in between, we don't roll back like a database. Instead, we run compensating action, means undoing steps. For example, if payment is done but inventory fails, we triggered a refund. Are you getting my point? Next question is, guys, if one service is getting heavy load, so how will you scale it? We can scale horizontally by adding more instance of the service and use a load balancer to distribute traffic. We can also enable auto scaling, so instances can increase or decrease based on the traffic. Are you getting my point? If needed, we can also optimize code or add caching to reduce the load. Okay. And the next question is, guys, you have 10 microservices with environment configs. How will you manage these configs across those microservices? So here we will use a centralized config management system where all configs are stored in one place. Each service will fetch configs from there. This helps in easy updates, consistency, and avoids hard coding in configuration in services. Are you getting my point? Next question is, guys, your service works fine in lower environment but fails in production. How would you debug it? First, we will check the logs to find the errors, compare configurations between environment and verify environment variable. We will also check the data differences and external dependencies. If needed, we could also try to reproduce the issue in staging environment. Okay. And the next question is, guys, let's say service A calls B, service B is down. So what would happen? So in this case, service A's request will fail or get delayed. To handle this, we can use retries with that limits, timeouts, and circuit breaker pattern to stop repeated calls. Also, we can return a fallback response so the system doesn't completely fail. Okay. One microservice is slow and impacting the system. What would you do? First, we will find the causing using logs and monitoring. Then we can optimize the codes, improve the database queries, or add cachings. Okay. We could also scale the service like adding more instances. Okay. Also, we could use timeouts or async calls to reduce the impact on the services. Are you getting my point? And the guys, next question is, how would you handle security in microservices? First, we will secure APIs using authentication and authorizations like JOT or OAuth, and use HTTPs for all communication. Okay. Then we will validate inputs, avoid exposing sensitive data, and use API gateway for centralized security. Okay. Each service should have proper access control and secrets should be stored securely. Next question is, when should we not use microservice architecture? So this is very important question. So we should not use microservices for a small or simple application. If the team is small or not experienced, it adds unnecessary complexity. Also, if a strong coordination and fast deployment are needed, monolithic is better. Microservices are useful only when the system is large and needs scalability. Okay. So guys, this is all about microservices, important and tricky scenario based question. And if you find this video helpful, please like and subscribe. And guys, if you want more questions, then please comment out. I will create another video on microservices to cover more scenario based questions and tricky questions. Okay. So till then, thank